The notes for Unit 7, Lesson 5 will cover dilutions. So after these notes, you should be able to describe the process of dilution, and we'll be able to calculate the unknown variable using the dilution formula. So some of these terms we have already referred to. So make sure you have your notes available. This is the last topic that we'll cover before the test. So dilution is the process of adding water to make a more concentrated solution weaker. So you take your concentrated solution and then you add a specific amount of water to it to make a new concentration. So the equation that you'll use is M1V1 is equal to M2V2. The M for both equations represents molarity. The V for both equations represents the volume of the solution. And so to keep the M1V1 and M2V2 separate, one side is going to be your stronger or more concentrated solution. And then the other side, the M2V2 for example, is going to be your weaker solution. So remember, the weaker solution means at a lower molarity value. So the higher the molarity value, the stronger and more concentrated the solution is. All right, so if you were in the lab and actually doing a dilution, there's kind of a specific way that you have to do it. Once you solve the problems and you figure out like how much of the concentrated solution you need, your stock solution is your concentrated solution. So say you figured out that you needed 15 milliliters of your stock solution. So you take out 15 milliliters and you add that 15 milliliters to, these are called volumetric flasks. So they don't have any markings other than one. So if this was a, like, for example, 250 milliliter volumetric flask, the mark here would represent 250 milliliters of solution. So if you add your 15 milliliters of your stock solution, so that would be your super concentrated solution. So we have 15 milliliters in here right now. Then to make the 250 milliliters of your new weaker solution, then to that 15 milliliters, you just add water until it, this total volume of the solution ends up meeting that mark. So then once you add the water, a specific amount of water, that would give you your more dilute solution. So once you solve these problems, then it's also taking the numbers and figuring out, okay, well, what would I actually do to make this weaker solution? So those are the steps that you would use to actually perform a dilution in the lab. All right, so if this was our problem, how many milliliters of a 12 molar solution of HCl are needed to make 250 milliliters of a 1.5 molar solution? So first of all, we want to know how many milliliters. So we want to know a volume. We are given 12 molar HCl solution, and we want to make 250 milliliters of a 1.5 molar solution. So if you compare your molarities, 12 molar compared to 1.5, obviously 12 molar is your stronger solution. So when you have your M1V1 is equal to M2V2, if M1V1, yep, is your stronger solution, then that 12 molar would be your M1. And we want to know how many milliliters of that do we need. And then if M2V2 is your weaker solution, this is the one we're trying to make, we want to make a 1.5 molar solution, and we want to make 250 milliliters of it. So in the last lesson, you learned about molarity. Molarity, the units had to be moles per liter. For dilutions, since we have one side is equal to the other, as long as the volume units match up, you can use milliliters or you can use liters. So you can keep this in milliliters or you can convert it to liters and you'll get the same answer. So to solve this, we would have our 12 molar solution times V1. And then we'd multiply 1.5 times 250, which would give you 375. I'm just going to keep both units here. And then to get V by itself, we would want to divide each side by 12 molar. And then molarity cancels out. So if we have 375 divided by 12, we get 31.25. And again, since the units here were milliliters, then the volume would be the same. Or the unit for volume would be the same. So now we figured out, oh, sorry, we have to round for sig figs. So 12 molar has 2 sig figs, 250 has 2 sig figs, 1.5 has 2 sig figs. So we would need 31 milliliters of this 12 molar solution. So again, if we were actually making the solution, we would measure out 31 milliliters. This is going to be a beautiful graduated cylinder. So we would fill this up with 31 milliliters. We would add it to our volumetric flask, or beaker in this case. And then once we have our 31 milliliters of solution, then we would fill the rest of it up with water. We want a total of 250. So then we'd just add water until the total volume hit that 250 milliliter mark. So that's how you would make this solution. And then once you have this solution, that would have a molarity of 1.5. So we would have diluted it from 12 molar to 1.5 molar once these solutions mixed. All right, last problem. We want to know how many milliliters of a 0.750 molar solution of NaCl can be made from 10 milliliters of a 5 molar solution. So we have a 5 molar solution available. We're going to use 10 milliliters of it, and we're diluting that substance. So here's our M1V1 is equal to M2V2. For our stronger solution, we have to compare the molarities. So 5 molar is much stronger than a 0.75 molar. So we have our 5 molar solution here. We know that we are using only 10 milliliters of that solution. And now we're trying to make a 0.750 molar solution, but we don't know how much volume that will take up. So this would be your setup. And then you would, again, just multiply the values on the left. So 5 times 10 is going to be 50 milliliters, or I guess we'll leave both units here, is equal to 0.75 times V2. And then to get V2 by itself, we would divide each side by 0.750 molar. Molarity cancels out. Here, molarity cancels out. Sorry, on the right side, both the unit and the values would cancel out. All right, so then V2 would be 66 point, a lot of sixes repeating for the volume. And then if we look at sig figs, 0.750 has 3 sig figs, 10.0 has 3 sig figs, 5.00 has 3 sig figs. So I'm going to keep 3. So we would end up with 66.7. Since our first volume is in milliliters, the second volume is also going to be in milliliters. So again, as long as those units match up, then we'll be good to go. So for this solution, basically you're starting out with your, 10 milliliters of your stock solution, which is the 5 molar solution, so that stronger solution. And then once we pour those 10 milliliters into the beaker, then in order to make this solution a 0.75 molar solution, we'd have to add water until the total solution got to 66.7 milliliters. So we'd add those 10 milliliters in of the stock solution. And then we'd have to add 56.7 milliliters of water to get the total volume to equal our 66.7. And then if we do that, then that would produce a solution that has a molarity of 0.750. So we have to do this a lot in the lab normally. So when we are making like hydrochloric acid for different labs and demonstrations, we have to take our concentrated acid and dilute it. So this is the process and the calculation that we use. So as always, let me know what questions you have.